So what does this experiment say to us? Well, the experiment says that there are substances, there are certain fuels that when you burn them, they vaporize directly. Such substances produce a flame when they are burning. But on the other hand, there are substances which do not vaporize, they do not form a flame. Example, fuels like petroleum products, kerosene oil, wax, petrol, diesel, all these directly vaporize as soon as they start burning. Hence, when they are burning, they create a flame. But fuels like coal, also. So when we burn them, they do not get vaporized. Hence, when they are burned, they do not form a flame. So this is the reason why we have a flame when we burn a candle, but we do not have a flame when we are burning a piece of charcoal. We have another experiment based on the things that we discussed about the structures of flame, where we have the innermost part, which is unburnt wax, the middle zone where we have partially burnt wax or we have partial combustion, and the outermost zone where we have complete combustion. So in this experiment, what we are going to do is, above the candle, we will put a slit of glass. This is called a glass slit, and we'll place it on the flame. After a few seconds, you will notice that the glass slit will have a blackish circle portion on the glass lid. Why this happened? Well, this is happening because of the unburnt part of the yellowish zone. The yellow zone હતો એમાં there was some unburnt portion of the wax. And we know, like, mostly when we burn this kind of fuels, there is carbon in them. So the unburnt portion or the unburnt carbon of the luminous zone gets formed here. It gets collected on the top, and that is why we see a black portion. And it is because of this experiment we know that flame we have three different zones. The innermost zone, which looks almost blackish part, is filled with unburnt wax. The middle zone, we have a partial combustion. So we have partial combustion here. The color of this zone is yellowish orange, but the outermost part, where we have complete combustion, has a bluish color. The outermost part is again the hottest part. The middle portion is moderately hot, and the innermost part is the least hot. So these were the discussion regarding the various structures of a flame, and this usually happens in all the flames. In some flames, you might observe that the flame is in blue color. जैसे कि हमने पहले डिस्कस किया था कि આપણે જે ગેસ પર ગેસનો ચૂલો હોય એને આપણે જ્યારે લાઇટ કરીએ, you will observe that there is a blue flame. The example is right here. Yeah, so this is an example of a blue flame. Why there is a blue flame? તો આપણે કહીએ તો આમાં તો કઈ orange part નથી, તો we can say that there is complete combustion. Exactly. When we light our gas using LPG, all portion of the LPG gas is burnt completely. So we can say that there is no vestige of, or we can say there is less vestige of fuel. But in the case of wax, there is a larger portion of yellowish color. So you can say there is a more vestige of fuel. So whenever you observe a blue flame, you can say that the fuel has burnt completely, or there was complete combustion. But if you observe a yellowish or orangish flame, you can say there was a partial combustion. There is another example given that अगर कोई सोनी ની દુકાને તમે જાઓ, or if someone of you is having a goldsmith shop, you might have observed that when they are preparing a gold, they have a thin pipe. They are thin metallic pipe like this. And how are they blowing? They are blowing in the outermost part of a flame. Why they are blowing on the outermost part of the flame? Because they know that the outermost part is the hottest part. So gold ne jyare apne pighlavu hoy, when we want to convert the gold into a bit liquidish form, so we need to give more heat. How can we get more heat? Because we can get the more heat by the outermost part of a flame. So that's all about the portions of flame. Now let's see some details about the fuel. So what do we expect from a fuel? After this experiment of candles, we know that the fuels that we use should be cost effective, बहुत ही सस्ता चाहिए. It should be also be highly efficient. जैसे अपना हम LPG gas use करते हैं, it burns completely. So I can say that I want a fuel which is highly efficient, which is also very cheap, which also should produce lots of heat so that I can use it. But we know that these kind of ideal situations we cannot get. अपना पेट्रोल कितना महंगा हो गया है? It's almost 80 rupees a liter. Its efficiency is good. Petrol will give you good efficiency, but what happens is it's very costly. On the other hand, charcoal or wood is maybe less effective, but it is very cheap. We have cow dung, જે આપણે ગાયનો ગોબર બનાવીએ, we let it dry. It is also used as a fuel. It is very cheap. It's almost free. But what happens is it is not as efficient as petrol or diesel are. So each fuel has certain advantages and certain disadvantages. So let us see more details about the fuel efficiency. So how do we measure the fuel efficiency? As we discussed that there are certain fuels like cow dung, charcoal, petrol. આપણે બધાને compare કઈ રીતે કરીએ? So we can compare it on the basis of fuel efficiency. What is fuel efficiency? આપણે fuel efficiency કઈ રીતે find કરીએ? Well, we can find it with the help of a term called calorific value. દરેક fuel has a predefined caloric value for it. What is calorific value? The calorific value is nothing but the amount of heat energy produced by burning 1 kg of that fuel. હું કોઈ પણ fuelનો 1 કિલોગ્રામ લઈ એને બર્ન કરું અને મને કેટલી હીટ એનર્જી મળે છે એને હું માપું. That is nothing but the calorific value of that fuel. So you can say कि suppose I have a charcoal, so I'll collect 1 kilo કોલસો રાખીશ અને burn કરીશ, I'll find its calorific value. 1 kilo wax લઈશ and now burn કરીશ, I'll find the heat energy and I'll get the calorific value. I'll do a similar thing for petrol. I'll do a similar thing for diesel. પણ ડીઝલ ને પેટ્રોલ તો લીટરમાં મળે છે, એને આપણે કિલોગ્રામમાં કઈ રીતે કન્વર્ટ કરીશું? So I don't know if you guys know this, but there is a formula like density is equal to mass divided by volume. So you can say that volume is equal to mass upon density. આ એક ડેન્સિટીની ફોર્મ્યુલા છે. So what is density? It is mass upon volume. Volume ને હું right side left side લઈ જઈશ, so I get volume is equal to mass upon density. So when I say I have a 1 liter of petrol or diesel, I don't know its mass, but I can know its density. મારે શું કરવું પડશે? પેટ્રોલની ડેન્સિટી ફાઇન્ડ કરવાની, and then I can find the mass of a petrol. Since I need only 1 kg of petrol, what I can do is I can say volume of petrol in liters is equal to 1 kg of petrol upon the density of petrol. Now the density of petrol is almost around 750 kg per meter cube. So we have another term called meter cube. And don't worry, this is just for the purpose of learning. So I know unit is meter cube. Now 1 meter cube has 1000 liters. So again it would be 1000 liters divided by 750. It would come around something like 1.33 liters. So when we accumulate 1.33 liters of petrol, it will weigh exactly 1 kg. And 1.33 liters ne apne burn kariye, and the amount of heat energy we will get will be called as the calorific value of petrol. Now what is the unit of calorific value? The unit of calorific value is kilojoule per kg. Per kg we know because આપણે 1 kg નો જ fuel લઈએ છે. The amount of heat energy, the unit of energy is joule. But there is so much of heat energy we get when we burn 1 kg of fuel. Hence we measure it in kilojoule. So let us have this table is just for reference. So as you can see here, we have the fuel of cow dung, which will give us around 6,000 to 8,000 of calorific value. We have wood, which will give around 17,000 to 22,000. But these are nothing as compared to petrol, kerosene, diesel, methane. એ બધાનો કેટલો છે 45,000 છે. The LPG or CNG that we use has around 50,000 to 55,000. The biogas, if we use, will have around 35,000 to 40,000. But the highest is hydrogen gas. We know hydrogen gas is highly combustible. What is the calorific value is? The calorific value of hydrogen gas is 1,50,000. Now આપણે ખબર છે ને કેમ આપણે હાઇડ્રોજન ગેસ are used to bombard some countries જ્યારે આપણે એટમિક યુદ્ધ થાય છે. There are certain world wars. What do we use? We use hydrogen bomb. Why? Because it has a such calorific value. It burns lots of energy. So this is the reason why hydrogen gas is used to create bombs. So far we have discussed various types of fuels and their fuel efficiency. Now what happens is when you try to burn certain fuels, it produces toxic products in the atmosphere, all harmful products in the atmosphere. So let us look at them in details. Firstly, mostly we have carbon fuels like wood, charcoal. These are all made up of carbon. So when we burn them, we have some unburned part of carbon left. And if you might have known that previously mostly in the village areas, they still use wood as a main fuel because it is very cheap. But what happens is there are unburnt particles of charcoal which vaporizes in the air, and when we exhale or when we inhale them, we get sick. આપણા જે ફેફસા છે, our lungs, they get highly damaged because of the carbon portions in this left out fuel. So this causes various diseases like asthma. So we can say that it is not recommended to use the wood or charcoal as a fuel. Next we have, as soon as we burn them, there is unburnt or incomplete combustion. This causes a gas called carbon monoxide. This is very poisonous gas, carbon monoxide, and it is very harmful for our environment. We also know that when we burn certain carbon elements like carbon plus O2, you might have learned in your chemistry, it produces carbon dioxide, CO2 gas. When CO2 gas rises and adds in our atmosphere, it is the reason for the greenhouse effect. What is greenhouse effect? The greenhouse effect is caused when there are sun particles, when the energy of sun is stored into our atmosphere, and the temperature of the atmosphere gets high. This is the reason for global warming. So carbon dioxide अगर atmosphere में ज़्यादा आ जाता है, it will create global warming. Again, there are certain diesels and petrols. When we burn them, it produces non-metallic oxides. What are non-metallic oxides? You might have learned in your chemistry. Sulfur, nitrogen. So these are the gases that are released, like sulfur dioxide and nitrogen dioxide. So when these oxides of nitrogen and sulfur are released in the atmosphere, they are highly soluble in water. What is soluble? કે પાણીમાં આપણે એડ કર્યો નો, so they will be soluble in water. When this gets soluble in the water vapor in the atmosphere, they form clouds in the atmosphere. So when these clouds are raining, it will have an amount of acid in the atmosphere, and this gives rises to acid rain. So because of these reasons, it is not advisable for us to burn these fuels, but we are left with no options. We also need petrol, we also need diesel, we also need charcoal for certain industries. But burning these fuels ultimately pollutes our environment, ultimately pollutes our atmosphere, and when we breathe in such air, we get damaged, we get health diseases.